Section 3.4, this is part of what is for this week. The blank represents the number of standard deviations an observation is from the mean. So let's look at our choices. Is it the quartile, the z-score, the range, or the percentile? It's the z-score, it's the standard score. The z-score represents, that's how many standard deviations something is from the mean. And this allows you to compare two data sets that may not have the same mean and standard deviation, but you can compare two things about how far they are from the mean in terms of standard deviations. The example I use in the lecture is the Colorado Rockies and the Angels. The Angels are in the American League, the Rockies are in the National League, who had a better run producing year, and we talk about the mean and the standard deviation of American and National League teams and that kind of thing. Blank divide data sets into fourths. All right? So even if you hadn't looked at anything, don't know whatever, you probably can get this one right. What do you think divides it into fourths? Outliers, quartiles, ranges, or z-scores? Quartiles, right? Right, quarter, quartile, quad. The quad's in the band, right? It's 4 drums. So, fantastic, it says. And I do like this about stats. It will tell you something, not just yes or no, many times. All right? Even more so, in my opinion, than the algebras and stuff. All right, so here in a certain city, 20 to 29-year-old average man is 69.6 inches tall with a standard deviation of 3.2 inches. The average woman is 64.1 inches tall with 3.8 standard deviation. Who is relatively taller, a 75-inch man or a 70-inch woman? All right, so the man is taller by 5 inches, but who is relatively taller based on the mean and the standard deviation? So let's actually figure that out. Let's look here. So the man is, let's see, this is mu for the men, and this is the standard deviation for the men. And I don't know, maybe that should be S or whatever, but let's see, and then this is the mu for the women, and this is the standard deviation for the women. So this is the X for the men, and this is the X for the women. So the z-score for the men is going to be the X minus the mean, so the 75 minus the mean is 69.6 divided by what? The standard deviation, which is 3.2. So this is where, like, if you have your calculator, I'm really going to need y'all to help me out, even if it's your cell phone calculator, which you typically wouldn't use. You can do that. So just to help me out to get these. And the z-score for the women is going to be 70 minus 60. What is it? 60. Where is it? 64.1 over 3.8. So that's going to be 5.4 over 3.2. You know what this is? 5.4 over 3.2? Yes. Which is how much? Give it 2 decimal places. 1.69. All right. And then what about the other one that's going to be, what, 5.9 over 3.8? And what is that? Is that right? Is it 5.9? 0.55, and we're about to know because it's going to make us type those numbers in. So the z-score for the woman is blank. For the woman, blank is larger than the z-score for the man. So that's not true. It won't be A, right? A says the woman's is larger than the man's. It's not. Hers is 1.55. The man's is 1.69, which is a little bigger. So the z-score for the man is larger, smaller. Okay, so it should be B, right? So I'm going to have to erase this. When I pick the mouse here to choose this, it's going to, just remember 1.69, 1.55, right? So when I pick this, it's going to go away, or it's gone away. So B. All right, so we said this was 1.69 for the men. And then here, the woman was 1.55. All right, so let's check it and see. Nice work. Good job. So 3, 4, 13 here. A highly selective boarding school will only admit students who place at least 2.5 standard deviations above the mean. It has 300. The mean is 300. The standard deviation is 26. What is the minimum score that you must make to be accepted? So whatever test they're given has a mean of 300 and a standard deviation of 26. They only take people who are at least 2.5 standard deviations above the mean. So what is the z-score for the test? Well, the z-score for the test is going to be, x minus mu over sigma. Well, we're wanting to know this, right? There's the cutoff score. We know that the standard deviation, the z-score is what? This is the z right here. So 2.5 equals the cutoff score, x, minus what's the mu? And then the sigma, right? So we're using the same formula. We're not plugging in x, mu, and sigma and getting z. We're given z here. We're trying to find x. Trying to find the score. So x minus 300 over 26. So we do 26 times 2.5, 65, I believe, equals x minus 300. And then we add 300. So we're going to multiply by 26. Somebody do 26 times 2.5, see if that's 65. And if you don't, we're about to find out if it's right. I'm going to get it right or wrong when I put it in. So then I add 300 to the other side, so 365. So if I take this test, if I score 360, I'm not going to get in. I didn't make high enough. If I score 370, I made high enough. That doesn't mean I get in, right? This is a minimum score to be accepted. I guess if this is their only criteria, but like for instance, nursing school, you have to make at least an 18. At a certain nursing school to get in, or maybe it's a 15 for a PN program, or it's a 21 for a RN program, or whatever. So whatever that minimum score is, that doesn't guarantee you get in. But if you don't make that score, they won't look at your application, right? That you have to meet that score for them to look at your application. So 365. Let's look here. Nobody told me anything, so I'm going to assume that if you did it, it was that. So 365. All right, well done. Explain the meaning of the following percentiles. The 10th percentile of the weight of males 36 months of age in a certain city is 11 kilograms. The 95th percentile of the length of newborn females in a certain city is 53.3%. So if something is a percentile, then everything is at or below that level. That percentage is at or below that value. So, for example, like when you took the ACT, because we're an ACT state, so if you took the ACT, if you took the SAT, you got the same thing. But if you took the ACT, right, and you're like me and you got your English score in and it was really low and it said you were in the 20th percentile, that means you only beat 20% of the people that took the test. 80% of the people beat you, okay? Now, my math score was better. I was in the 99th percentile of the math. That means I did better than 99% of the people in the country that took the ACT when I took it, okay? English and reading was even worse. It was like I was like the 4th percentile or something. And I feel sorry for those 4%. Okay? So, but that's what a percentile means. I'm being a little facetious there. It wasn't the 4th, and I don't know that I was the 99th. I think I was, all right, in the math. All right? But the point is the percentile, whatever it says, if you're in that percentile, then that number or less made, so like if I just think about, this is talking about babies. But when I take my kids to the doctor, they're 16 and they're 12, they still tell us, your son is in the 30th percentile of height and weight. Your daughter's in the 60th percentile of height and the 20th percentile of weight. Or whatever, okay, because she's a little beanpole. Well, just on my son's baseball team, Lawson Fortner is huge. He's the same age as my son. He's going to be in the 70th percentile of 12-year-olds in America. He's a big, strong kid. There's not going to be many kids that age bigger and stronger than he is. My son, on the other hand, is a little scrawny runt, and so he's going to be like in the 30th percentile, where 70% of the kids at his age are bigger than him. So, and that happens especially in that age range for boys, especially because they hit their growth spurts at different times. So, But that's what percentiles are. So here, if I'm the 10th percentile, that means that 11 kilograms, what percent are at that 11 kilograms or less? 10. If it's 11 kilograms or more than 11 kilograms, it's going to be what? 90%. And then on the other one for the females, 95% or less than 53.3 centimeters long at that newborn, okay? So which one, A, B, C, or D? Let's see. 10% weigh more, it can't be A, right? It can't be A because that says more. That's no good. 10% of males or more, can't be that one. 10% of males or less, that's good. But then it says 90% or more than the 11. Well, wait a minute. That makes some sense, but that doesn't talk about the, and 90% of the, oh, this is just the first part. All right, so then 10% of the males weigh less and 90% weigh more. Aha. Look at the difference between C and D. This just says 10% of males weigh that much. It doesn't say 36-month-old. And we're talking about what? 36 months, right? So then I'm looking at this thinking it probably should be C because it distinguishes between that and D by saying 36 months old. So let's look and see. May not be right. All right, fantastic, it says. All right, then we're going to hit continue. And now it's going to talk about the next part. So 95% of the females have a length of 53 or less. That's got a chance. Look at B. It doesn't say newborn, so throw it out. C is more and D is more, so then it's got to be A. Right? B doesn't talk about newborn, and then C and D are both more, and its percentiles less. Percentiles less. The accompanying data represent the miles per gallon of a random sample of cars with a 3-cylinder, 1-liter engine. I don't know much about vehicles, but I always thought they were even number of cylinders, but maybe not. Compute the Z-score corresponding to the individual who obtained 39.5 miles per gallon. Interpret the result. So, do I see data up here? No, what do I look at to look at the data? There's this little icon, right? Click this to see the data. There's the data. And one nice thing about this, you have four rows, and you have 1, 2, 3, 4, 5, 6 columns. So how many data elements are there? Well, 4 times 6 is what? 24. There's 24 data elements. And the other nice thing about this is they have already put them what? Look as you go down each column. They're in what? They're in order from smallest to biggest, right? So that way, that's nice. If you had to find the median, or if you needed to find the mode, or if you needed to find something else with that, it's already in ascending order. So that makes it a lot easier for you to do that. You could count through and get those things if you needed to, which we're actually going to do because it says determine the quartiles on B. But it says compute the Z-score corresponding to the individual who obtained 39.5 miles to the gallon. So here, it does not give us what? The mean, nor does it give us the what? Standard deviation. And I didn't bring... Anybody have the little calculator that you can use in this class, the TI-30XIS? Might have it. So what I think I may can do, look at that drawer fell open, I opened the other drawer. Let's copy this. Let's just open an Excel. That's even better. Do we have Excel to open in? We're going to find out. Aha. All right, so then we can take, I'm going to go over here in this cell here. I'm going to type in equals average, which, by the way, if you type in the word average in in Excel, it's going to give you the mean. It's going to give you the mean. So let's go here, and then all the way down there. So there's your mean, and then what is the standard deviation? Let's see. Formulas. You see statistical. Let's go into the S's and see if it's like STDEV or something. All right. Do I not see statistical? Am I looking right? There it is. So look at standard deviation here. All right, standard deviation. Value one. Estimate standard deviation based on a sample. Okay, so let's do this. Where's my... So the average is 38.94583. The standard deviation is 3.518643. Remember, we typically go one decimal place further than the data. So if we look back at the data, how far does the data go? The data goes to one decimal place. So we want to go to two decimal places, 38.95 and 3.52. So somebody remember that, 38.95 and 3.52. 38.95 and 3.52. I've already forgot. So then, and if you had a calculator, you could do it on a calculator. If not, you can do it just like I did in Excel just then. I have that taken out. That's fine. So it wants the z-score to 39.5, which is this one, right? The z-score for that one. So our mu, or not mu, our x bar, because it's a sample, right? It says a random sample, yes. X bar is 38.95, and then S is 3.52. So then z-score for this is going to be 39.5 minus 38.95 divided by 3.52. And I hope that they went to two decimal places on this when they did this. So 39.5 minus 38.95 divided by 3.52, 0.16. 0.16. 156 is what it is. So we're going to say 1.6. What if they did to one decimal place? Let's just see if that's the same answer. 39.5 minus 38.9 divided by 3.5. 0.17. So it's a little bit different answer. We'll see. I'll put in 0.16 first. We'll follow the... So done here. The z-score corresponding to this individual is 0.16. And you can put 0.16 or 0.16. It indicates the data value is blank standard deviation, so it's 0.16. That's not 1Q6, 16. Standard deviations, which way is it? Is it above or below? What do you think? If the standard deviation is positive, is it above the mean or below the mean? Above. And you can also look at the value. Our mean was 38 something, and this value is 39 something, so it's above, right? Above the what? The mean. So let's check the answer. Excellent. All right. And then determine the quartiles. How do I determine the quartiles? Well, the quartile, I didn't mean to do that. The quartiles are the median. The median. So we have 24 values. We go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So this one and this one are the middle two values. So if we take 38.6 plus 38.5 and we divide by 2, we get 38.55. And 38.55 is the median, which is also known as Q2. Okay? Right? If they're quartiles, if you divide the data into quarters, and the median is halfway in between, then how many quarters fall below the middle point? 2 of them. How many fall above the middle point? 2 of them. So that's why it's called Q2. So how do you suppose I'm going to find the first quartile and the third quartile? I'm going to find the median of this data, right? So here I have 12 on this side. So go 1, 2, 3, 4, 5, 6. It's these 2 right here. Q1 falls right there. The way we find the median, right, if it's an even number, we add the 2 middle values and divide. So Q1 is going to be 36.3 plus 37.4 over 2. And that's going to be 36 point, let's see, 4 and 4 is 7. So 36.85. If that's not right, well, somebody can check it, make sure. That doesn't look right. 5, 5, and 5, 5. That is right. Okay, 36.85. And then Q3 is the same thing. You come over here and you're going to take these 2 right here. 41.5 and 40.6, which 4 and 4, 40. 40.05 should be Q3. So I'm going to take a picture of that so I can remember those values. Although I can't hardly read my writing. All right, so here, what is Q1 we said? We said Q1 was 36.85. Let's try that and see what happens. 36.85. All right, excellent. And then it's going to ask us for Q2, which is also the median, which we said was 38.55. All right, notice I clicked in it, it didn't work, it jumped, clicking it again. That's a little, my stat lab or my math lab quirk there. Sometimes it goes in there, sometimes it doesn't. All right, so the second quartile, I hit an extra button. So, yeah, it won't be 398 anything. 38.55 is what we got. Let's check that. There we go. And then Q3 we said was 40.05, so if we did that correctly and had to hit it twice again because the screen jumped when you clicked in it. And that's incorrect, 40.05. So what did we do wrong there? 40.6, 41.05. 41 is 41. I wrote down 40, but it was 41, right? It's between 40.6 and 41.5. 40.05 is below both of them. 41.05 is there, so that should be the correct one. There we go. So what is the interquartile range? The interquartile range is going to be Q3 minus Q1. It's the middle 50%. You take the top 25% off, the bottom 25% off, the middle 50%. It's called the IQR for short, all caps, all IQR in caps. So, well, hang on. Let's move it back up here. It's going to be 41.05 minus 36.85. So it's going to be whatever that is. 4.2. No. Yeah. 4.2 is the interquartile range. And so let's see what it is. It is the range of observations between the upper and lower fences? No. It's the range of observations between either the lower and upper quartile and the middle quartile? No. It is the range of the middle 50%? Yes. And it's not the range of all the data set because that's the actual range. So it's going to be this middle 50%, and we said it was 4.2. Let's see if we did that right. I didn't punch it in. I just tried to do it in my head, which got me in trouble on one of the other ones. All right, there it is. So the interquartile range is Q3 minus Q1. Q3 minus Q1. Now the upper and lower fences. So how do you find this lower fence? Okay, and we said, why are we talking about a fence? I got a fence in my yard. I know. But when we talk about data, we want to talk about outliers. What's inside the fence, what's outside the fence, that kind of thing. And so when we talk about upper and lower fences, the lower fence is Q1 minus 1.5 times the IQR. It's Q1 minus 1.5 times the interquartile range. So our Q1 was what? 38 point something? 36.85. 36.85 minus 1.5 times our IQR was 4.2. So what does that give me when I do that in my calculator? Let's see. 1.5 times 4.2 is 6.3. So that's 30.55. So the lower fence is 30.55. So let's check that and see if that's what we get here. 30.55 for the lower fence. Oh, I hit comma. So hopefully that'll be right if I don't hit comma. I was trying to be European there. Right, they use commas where we use decimals and backwards. All right, so there it is, 30.55, lower fence. The upper fence. Well, if the lower fence is Q1 minus 1.5, then guess what the upper fence is? The upper fence is Q3 plus 1.5 times IQR. So plus 1.5 times 4.2, and this was 41.05, I think, for the Q3. So plus 6.3 is 47.35. So 47.35, I think, is what that's going to be. Again, it's a little dangerous. Didn't type that in. 47.35. All right. The outliers are, the outlier is, or there are no outliers. Well, here are outliers. Outliers are values that fall outside the fence. Okay, so anything below 30.55 or above 47.35. So let's look at our data again. Here's the lowest value. Is it below 30.55? The first one on our list? No. Is the last data value beyond 47.35? Yes. How many of them? Just the last one or more than one? That are bigger than 47? Just one of them, right? So the only outlier we have is this one. That's already less than that, and that's already inside the other, right? Everything else is in between the fences. But that 49.1 is not between the fences, therefore it's considered an outlier. So then here, I need to pick what? There are outliers, and it's what? 49.1. So 49, and if you had more than one, you would just put comma, like 49.1, comma, 49.2, comma, whatever. So, all right, so that one was a beast of a problem. I had all kind of sections and whatever, but that one problem is not terrible as far as all the stuff you have to do. It has some decimals in it, but I mean, you get the median, then you get the median of the lower half for Q1, the median of the upper half for Q3, then you subtract Q3 minus Q1 for the interquartile range, and then you have to know what the fences are. So be sure you look at, know that formula or whatever. I did give you on every one of these on this test, I gave you the blank notes, you have the filled in notes in Canvas, and you have the videos that fill in the notes. So, and then I'm going to post this video of the homework as much as we get done, which may only be this section. And I also have 2 problems from 3.3 worked, so I'll make sure that gets posted in there as well in the video section. The following data represent monthly phone use in minutes. The customer enrolled in fraud prevention for the past 20 months. The company decides to use the upper fence as the cutoff point for the number of minutes which the customer should be contacted. What is the cutoff point? So, are these things in order? No. So the first thing I'm going to do is do what? Put them in order. So let's do this again. Let's take this and let's open an Excel. It's going to open up first in the bottom of our window here. I thought it was. Oh, allow, yes. Because I already have one open. I guess that's what it's doing. So let's open this up. All right, so here's my data. You can click on column A. You can hit data. And you can sort from A to Z. And there it is in order, okay? So many of you know how to do this in Excel and that kind of stuff. Excel's really, really nice. So I think you can even go over here to, let's try it. Let's go to formulas, more functions, statistical, and let's look at quartiles, see if it has something for quartiles in here. quartile. I don't know what these things mean. EX and IN. Let's try it and see what that is. It returns the quartile based on the percentile. Huh? Array. All right, so let's look at the other one. I don't know exactly what that means. So let's look here. Quartile. That was the EXC one. Where's this other one? Oh, exclusive, inclusive. Okay. Returns the quartile of a data set based on the percentile values, inclusive. All right, let's do this. Let's do. Oh, I don't know what I just did. It's in the first cell there. We don't want to do that. All right, they're in order. How many are there? There's 20 of them. So where's the median? It's between 10 and 11, right? It's between these two right here. Well, where's it at? Between these two. So what I can do here equals A10 equals A10 plus A11 divided by 2. And there's the median. So this is M. And so then let's come up here and let's find Q1, and let's find here Q3. All right, and then over here we can find the IQR, and we can do that by saying this equals Q3 minus Q1. We can already have it set. Then we can come over here and go, okay, what's my upper fence? My upper fence. Well, my upper fence is going to be equals Q3 plus 1, that's not 1, 1.5 times my IQR. And if I want to do my lower fence, I can have that too. I can sit here and type all this stuff in with the formulas in Excel, and then when I go and find these values, I have it. So if I have 10 values, how many values are there? There's 10, so it's 5 and 6, all right? So it's going to be, the Q1 is going to be between 5 and 6, so it's going to equal, I don't know what I just did. I just messed everything up. All right. Come on. Equals A5 plus A6 divided by 2. And then same thing here, 11 through 20 is going to be 15 and 16. Right, that's the fifth and the sixth elements in there. 15 and 16 is an even number, so A15 plus A16. So it's going to equal A15 plus A16 divided by 2. And that didn't work. What did I do wrong? Oh. I just said plus 16 plus A16. So here's your Q1, your median, your Q3. Here's your interquartile range. Here's your upper fence. 669.25. So if we round it 669, let's see if that's 669. Let's see if that's what it says here. The cutoff point is the upper fence, 669. And excellent. There it is. Okay. Explain the circumstances for which the IQR, the interquartile range, is the preferred measure of dispersion. What is the advantage the standard deviation has over the interquartile range? So the interquartile range is preferred when the distribution is symmetric? No. If it is symmetric, we want to use the standard deviation, the mean and the standard deviation if it's symmetric. So A and B are out. We already know A and B are out, okay? Because they say symmetric. We don't want that. The interquartile range is preferred when the data is skewed or have outliers, and the advantage of the standard deviation is that it uses all the observations in its computation. That sounds really good. The standard deviation uses everything, and that's an advantage it has, right? The interquartile range is the middle 50%, right? It leaves things on the outside out of it. So that C sounds like a really good answer so far. The interquartile range is preferred when it's bell-shaped? No, when it's bell-shaped, that's standard, that's symmetric. We don't want that, okay? Not for the interquartile range. It's preferred when the data is not skewed? No, we don't want that. The interquartile range is when it's bell-shaped? No, we don't want that, so then C it is for sure. We don't want it when it's bell-shaped is symmetric. We don't want that. We want standard deviation for that, so then this is definitely C. Definitely C here. So, all right, and then it gives you some words there about that. All right, so this is section 3.4. I hope it helps out with, I mean, you got to go do this on your own if you haven't done it already. So, and then, this week is 3.3, 3.4, 3.5. But again, I'll post some videos of 3.3 out there as well. But this is section 3.4. All right? So if you have questions, hang around and ask me. If